Welcome back to the Deep Dive.
Great to be here.
So today's mission, and this one comes directly from a listener request, is to tackle a document that is, well, it's ambitious.
That might be the understatement of the year. It's incredibly dense.
We are diving into the latest version of the Unified Chronofractal Field Theory, or UCF, specifically version 6.0.
And this isn't just a standard research paper from a university. This is an independent document from Heiko Grimberg, but with a fascinating twist.
The audit. It was audited by something called the Nexus AEBE algorithmic entity.
A collaboration between human intuition and pure machine logic. The title alone tells you everything about the scale of the claim here.
It does. The zero parameter limit. That one word zero is really the anchor for our whole conversation today. Our listener wanted us to look past the current crisis in cosmology.
The crisis of parameters.
Exactly. And to really examine this audacious claim that the entire universe, everything from the acceleration of the cosmos down to how a galaxy spins,
is not about ingredients. It's not about finding some new particle.
It's just geometry.
A geometric inevitability, to use their exact phrasing.
Okay, let's unpack this.
Let's do it.
Our goal here is to walk you through, step by step, how this framework claims to get rid of every single tuning knob in cosmology.
Every single one. The whole idea is to base everything, and I mean everything, on just two pure mathematical constants.
And these are constants you can actually derive.
Exactly. The first is the fractal dimension of time, which they call mu.
And the second?
The topological limit of space, which, and this is the big reveal in this version, it turns out to be pi.
Pi. As in 3.14159.
The very same.
That's wild.
Yeah.
And the timing of this is key, right? The document is dated December 21st, 2025.
Yes, and that date marks a huge shift. Before this, UCF was a really good empirical model. It fit the data remarkably well.
But it still had some knobs to turn.
It did. With version 6.0, it transitions to a purely axiomatic theory. It's saying, here are the geometric rules. Physics must follow, not the other way around.
It's the ultimate quest for simplicity, for parsimony in the universe.
That's the goal.
So to really get a handle on how audacious this zero parameter thing is, we have to start with the current champion.
Lambda CDM, the standard model of cosmology.
Right. It's been the reigning model for decades. But this new document pulls no punches. It calls Lambda CDM a... what's the phrase?
A triumph of descriptive fitting, yet a failure of explanatory parsimony.
That's a pretty sharp critique.
It's a damning assessment. I mean, it's saying, yes, your model works brilliantly, but only because we let you cheat.
We let you look at the answers before you wrote the equation.
Precisely. You measure key cosmic numbers, and then you slot them into the model to make it work. The model itself doesn't predict them.
And we're talking about a lot of these numbers. The document says over 20 free parameters.
More than 20, yeah. It's things like the exact density of dark energy, the density of dark matter, the initial lumpiness of the universe.
I love the analogy of a stereo system with 20 equalizer knobs. Bass, treble, all that. And you're just sliding them all around until the music sounds right, but you don't actually know why those are the correct settings.
That's it, exactly. They have to be inserted by hand. That's the phrase they use. They aren't derived from first principles. And that, right there, is the crisis of parameters.
A truly fundamental theory shouldn't need you to tell it what the answer is.
It should give you the answer.
And this is where UCF v6.0 just draws a hard line in the sand.
Absolutely. The requirement is non-negotiable. Zero free parameters.
So every constant, every density, every rate of expansion
has to be a mathematical derivation. It has to fall out of the geometry of space-time. If you can't derive it from the basic axioms, it's out. It doesn't belong.
Okay, so that brings us to the first of those axioms, the foundation.
Axiom 1, the engine of time. This is the constant they call in.
And this is where it gets really mind-bending, because the theory isn't just about space. It's about the fundamental nature of time itself.
Right. It frames the universe as a sort of information processing system.
A self-referential system that's constantly trying to optimize how it stores memory, how it retains information.
And that optimization process, that drive for efficiency, leads it to settle on a very specific mathematical point. It's called the renormalization group fixed point.
Okay, break that down for us.
Imagine you have a huge, complex system, like a simulation of the weather. You want the rules of that simulation to work just as well, whether you're looking at a continent or a single city block.
It has to scale properly.
It has to scale. The fixed point is the mathematical rule that allows the system to scale perfectly without its fundamental character breaking down. The universe, according to this theory, found its own fixed point.
To be as informationally efficient as possible.
And that optimal self-similar scaling is governed by an incredibly simple equation.
Let me see if I have it here. Squared plus e minus 1 equals 0.
That's the one. It looks so simple, but that defines the entire engine.
And the solution to that equation, the positive solution, gives you the value of a Banny?
Yes. E equals the square root of 5 minus 1, all divided by 2.
Which is, wait a second, that's the golden ratio conjugate.
Yeah, approximately 0.618034.
Yes, the golden ratio. The number you see in seashells and sunflowers and Renaissance art, you're saying that's the number that dictates the flow of time?
I know. It sounds
almost mystical, like someone was looking for a pattern and forced it to fit.
And that's the key. They claim they didn't look for it. It emerged from the mathematics of information entropy. It wasn't fit to data from a telescope.
Okay, so what's the physical meaning of this 0.618 number?
It means time isn't just one-dimensional. It's not the smooth, flowing river that general relativity assumes.
It's fractal.
It's fractal. Its true dimensionality is dt equals 1 plus...
So 1.618?
Exactly. And that tiny excess dimensionality, that little bit of extra structure in time...
That's the engine.
That's what creates a persistent negative pressure everywhere in the vacuum. And a persistent negative pressure pushing things apart is...
Dark energy.
Dark energy. It isn't a substance. It's a consequence of the fractal geometry of time.
Wow. Okay, so that's the engine. Now let's talk about the boundaries, the shape of space, axiom 2.
This is where pi comes in, and it's the big breakthrough for V6.0.
Because in the older versions, they had a problem, right? A number they couldn't explain.
Exactly. To explain why galaxies spin so fast, they needed to include a mass damping coefficient. They called it eta.
And they measured it from the data.
They did. From looking at galactic rotation curves, they found they needed a value of E around 0.32 to make the model work.
Which was a free parameter. It was a knob they had to tune by hand, the very thing they wanted to eliminate.
It was the last big one. But in V6.0, they claimed they found its true identity. They realized it wasn't a random number, it was geometric.
So what's the logic? How does pi get involved in damping the gravity of a galaxy?
It all comes down to topology. Think about a galaxy's mass. It generates this historical wake we'll talk more about. That influence has to spread out into the vacuum around it.
And the vacuum is three-dimensional.
Three-dimensional and, at large scales, spherically symmetric around a point source. So any information, any potential radiating from the center has to be diluted by the geometry of a sphere.
Okay, so it's not just about the inverse square law for distance. This is about the shape of the space itself.
Precisely. And the geometric factor that defines spherical dilution in 3D space is pi. The topological damping identity, as they call it, states that E is strictly, necessarily, equal to 1 divided by pi.
Okay, let's do the math on that. 1 divided by 3.14159.
Gives you approximately 0.3183.
Oh, wow.
Yeah.
So their best empirical measurement from the data was 0.32.
Mm-hmm.
And the pure geometric derivation from first principles is 0.3183.
A deviation of less than 0.6%.
That must have been the moment, the eureka moment, where the theory clicked into place.
That's the moment the algorithmic audit, the Nexus AEBE, probably lit up like a Christmas tree. It's the universe basically saying, yes, you were on the right track. The tuning knob was hiding inside pi all along.
But I have to ask, pi is all over general relativity. How did standard cosmology miss this? Why did they need to invent dark matter?
That's a fantastic question. The UCF argument is that you can only see the one factor when you first accept that time is fractal.
Ah, so you need both axioms.
You need both. In standard GR, time is smooth, duality is 1. So when you see galaxies rotating too fast, the only way to fix the equation is to add more mass, hence dark matter.
But if you start with fractal time, with E,
then the interaction between that fractal time and spherical space naturally generates this new potential. The one damping factor just emerges. You don't need to add any new matter.
So you have the two axioms you have for time, for space. Now you can put it all together.
Into the unified master equation.
Which defines the effective gravitational potential. They call it the chi field.
Yes, and this is what replaces both the simple Newtonian potential and the complex dark matter halo models.
And if you look inside that equation, you can see the two axioms at work.
You can. It has two main parts. First, there's the chronofractal scaling term. That's to the power of Che.
So tau, representing time, raised to the power of the golden ratio conjugate.
That's the time component. It ensures the potential grows and deepens the longer a structure exists. It's the engine.
The thing that drives the acceleration.
And the second part is the spherical damping term. That's m to the power of -1 over pi.
Mass, damped by the geometry of space.
Exactly. That's the spatial component. It dictates the shape of the gravitational field.
So you've got time pushing things apart with n, and space holding things together, but damped by pi.
And critically, that's it. The document is emphatic that there are no other free parameters in there. Any other constants are just for scaling units, converting from kilograms to solar masses. They're not knobs you can tune to change the
The
physics.
physics is completely locked in by n and pi.
That's the definition of a zero-parameter theory.
Okay, we have the foundation. Now the big question, can it actually describe the universe we see? Let's start with the biggest mystery of all, the accelerated expansion.
Right. How does this number, this fractal dimension of time, give us an exact value for dark energy?
Because the standard model, lambda CDM, has a very simple answer. It just says vacuum energy is a constant.
A cosmological constant. The equation of state parameter, W, is exactly -1.
Yeah.
Done.
But UCF says, no, that's impossible.
It has to be impossible. Because if time itself is scaling fractally, then the energy of the vacuum created by that time must also scale. It can't be static.
So the source of the negative pressure is this temporal excess, this heat, which is about 0.618. But that's not the number we observe for W. Current measurements put W somewhere around -0.8, not -1.3 or something like that.
And that's where the geometry of space comes back in. They call it the third balance.
The third balance.
The repulsive energy is generated in the time dimension. But its effect, the acceleration it causes, has to be distributed across the space it's acting on.
And we live in 3 spatial dimensions?
3 spatial degrees of freedom. So the universe takes that raw temporal pressure and it divides it equally among the 3 spatial dimensions. It gets diluted.
As simple as that. You just divide by 3.
The geometric relationship is just that. You take the temporal excess and you divide it by 3.
So the deviation from a static vacuum is literally E divided by 3.
Which means the zero-parameter derivation for the dark energy equation of state, which they call W0,
is W0 equals -1 plus E divided by 3.
Exactly.
Let's run the numbers. E is about 0.618. Divide that by 3, you get, what, about 0.206?
Right.
So -1 plus 0.206 gives you -0.794.
The paper gives it to more decimal places, -0.793989.
And that is a non-negotiable geometric prediction.
It's a geometric necessity. The theory forbids W from being exactly no beta 1. It must be slightly less negative, and the deviation is locked in by the golden ratio.
That's incredible. It's like if we had never even built a telescope, but we understood this geometry, we could have calculated the rate of cosmic acceleration from pure math.
That's the claim. But it gets even better, because the vacuum energy can't be static. It has to evolve.
It's thawing.
It's thawing. And cosmologists have a way to measure that evolution. They use a parameter called Wa.
Right, so Wa just measures how Wa changes over time. If it's 0, W is constant, like in the standard model.
Correct. If it's positive, dark energy was stronger in the past. If it's negative, it's getting stronger now.
So what does this chronofractal geometry predict for Wa?
Well, if the main term, the deviation in W0, is proportional to E,
then the next term, the change over time, should be proportional to E squared.
Exactly. It's the second-order component of the fractal scaling. So the derivation for Wa is E squared divided by 3.
Still dividing by the 3 dimensions of space.
Still balancing it against the geometry. And squared is about 0.382. Divide that by 3.
You get approximately positive 0.127.
The paper gives was as plus 0.127322. A definite positive value.
And that's a huge deal. A positive Wa means dark energy was more powerful in the past, and it's weakening over time.
Right, which actually helps with some other cosmological tensions. It provides a smoother transition from the era when matter dominated the universe.
Okay, so all of this is building up to a massive confrontation, a showdown.
The Euclid trap.
The Euclid Space Telescope, a mission designed for one primary purpose.
To measure W and Wa with unprecedented precision, to finally settle this debate.
So let's lay out the predictions side by side. It's a clean fight.
In one corner, you have the standard model, lambda CDM. Its prediction is simple. W is exactly -1.00, and Y is exactly 0.00.
A static, unchanging cosmological constant.
In the other corner, you have UCF v6.0. Its prediction is derived entirely from the golden ratio. W0 must be -0.794, give or take observational error.
And Wa must be positive 0.127.
The stakes could not be higher. If Euclid comes back with a measurement of W0 right on Nevi's 1,
UCF is dead, instantly falsified.
but if Euclid measures W0 to be around Nevi's 0.8,
Then the standard model is in deep, deep trouble because a static vacuum would be ruled out.
It's a binary choice.
Right.
There's no middle ground, no way to tune the theory to escape. The data will decide.
So here, the golden ratio handles the cosmos. That means pi has to handle the galaxies.
Right. The whole dark matter problem. Why do galaxies spin so fast that they should be flying apart?
For decades, the answer has been that they're held together by huge, invisible halos of dark matter particles.
A huge amount of missing mass providing extra gravity. UCF says, no, the mass isn't missing. The potential generated by the mass we can see is what we've been miscalculating.
And the replacement for the dark matter halo is this idea of historicity.
Historicity. It's a historical wake.
Explain that. What is a historical wake?
Think of a heavy ship sailing on the ocean. The ship is your galaxy's visible matter. Each part of the ship is long gone. The water isn't perfectly still. There are ripples, a wake, a memory of its passage.
So the mass of the galaxy leaves a permanent scar or a memory in the fractal dimension of time.
Exactly. And that lingering temporal memory creates an effective gravitational potential well that extends far out, way beyond the visible stars.
It mimics the spatial effect of a dark matter halo without any actual dark matter.
That's the idea. It's this extra potential from the galaxy's history that keeps the outer stars orbiting so quickly. And the crucial part is that the shape of this potential isn't random.
It's constrained by the geometry of space.
Which brings us right back to pi. The damping factor, E, is identically 1.
The information from that historical wake has to spread out spherically, and so it's damped by a factor of 1.
It's a geometric break on the potential.
So you're telling me that these beautiful, complex maps of dark matter halos that we've spent decades creating
Are, according to this theory, just maps of spherical information dilution.
maps of them?
That's the claim. The patterns are not from the messy physics of particle clustering, but from the clean, elegant geometry of pi.
Okay, if that's true, it has to do more than just sound good. It has to reproduce the observations. And the big one for galaxies is the Tully-Fisher relation.
Ah, yes, Tully-Fisher. The observation that a galaxy's brightness, which is a proxy for its mass,
is very tightly linked to how fast it spins. Specifically, mass is proportional to the flat rotation velocity to the fourth power.
Right. And in the standard model, getting that relationship to work is messy. It involves huge, expensive computer simulations with all sorts of complex feedback from stars and black holes.
It's what they call an emergent property, not something you can easily derive.
UCF v6.0 claims it can derive it analytically, straight from the master equation. This is a huge test for the theory on the galactic scale.
Walk me through it. How does the math work?
Okay, so the flat rotation speed v flat is basically proportional to the square root of the gravitational potential. Out in the far edges of a galaxy, the theory predicts that this potential simplifies. It depends on the mass, m, raised to a specific power.
And that power has to involve the damping factor.
Exactly. The theory predicts that the velocity squared, v squared, is proportional to the mass raised to the power of 1 minus 1 over pi.
1 minus the geometric damping, so it's the part of the mass that isn't damped that sets the speed.
You got it. So 1 minus 0.318 is about 0.682.
Okay.
And since the velocity we measure is v, not v squared, you take the square root, which means you divide that exponent by 2.
So the final prediction for how velocity scales with mass is v is proportional to m to the power of 0.341.
A direct analytical prediction. Now, if you flip that around to match the way Tully-Fisher is usually written, luminosity versus velocity,
You get luminosity is proportional to velocity to the power of 1 divided by 0.341.
which is about 2.93.
And the observed relation is somewhere between v cubed and v to the fourth.
Yes, and the document points out that in the infrared band, where you get the best measure of mass, the observational data for many galaxies clusters very tightly around an exponent of 2.9 to 3.0.
So it's a remarkably good fit.
And it's derived without a single halo parameter, no feedback models, just geometry.
Let's make this concrete. The ultimate test case. The Andromeda Galaxy M31.
Perfect example. M31 is our biggest neighbor, it's the most studied, and crucially, it's the galaxy they used in the old empirical versions of UCF to measure that it was about 0.32.
So now they have to take their hands off the dial. They can't use 0.32 anymore.
They are forced to use the strict geometric value, 1, 1,
Yeah.
and see if the prediction still works. You can't tune pi.
Okay, so what are the inputs for the calculation?
Bare minimum. The baryonic mass of Andromeda, which is somewhere between 1 and 1.3 times 10 to the 11 solar masses.
Right.
Its age, about 10 billion years. And the two constants, n and mat. That's it.
And what does the master equation predict for its rotation speed?
The predicted range for the flat rotation velocity is between 220 and 240 kilometers per second.
And the measured observed value for M31
is 225 plus or minus 20 kilometers per second.
Let that sink in. The prediction from pure geometry, using only the golden ratio and pi, lands squarely inside the observational error bars.
It's an astonishing result. As Grimberg writes in the paper, no dark matter halo was constructed. It didn't need to be.
Okay, so UCF scales from the cosmos down to the galaxy. But any truly fundamental theory has to show up in our own backyard.
It has to have a local signature, something we can measure right here in the solar system.
And most modified gravity theories try to find weird spatial forces, right? Like the old Pioneer anomaly where a spacecraft seemed to be slowing down too much.
Exactly. They're looking for a deviation in the trajectory. UCF predicts something much more subtle. It's not a drift in space, it's a drift in time.
This is the distinction between the trajectory channel and the clock channel.
That's the key. Standard GR says gravity affects position. So any error should be in where the spacecraft is.
But UCF says time itself is flowing fractally.
Right. The rate of time's flow, dTdr, isn't exactly 1. It's 1 plus a tiny, tiny error term, epsilon. And that epsilon is a persistent bias. It's not in the position. It's in the clock you're using to measure the position.
So the navigation teams are looking for an error in distance, but the real error is in their stopwatch.
That's the argument. They're looking in the wrong channel. And UCF says we should be looking at the Deep Space Network link, the one between Earth and our probes at Mars.
And how do they calculate this drift from Ineta?
It's a bit more complex, but it comes down to a dimensionless fractal coupling factor. They call it ADTCF.
And that number is tiny.
Incredibly small, about 0.001376. That's the strength of the fractal effect in our solar system.
So how does that tiny number create a signal we could actually measure?
It piggybacks on a much larger effect.
Yeah.
Even in standard GR, because of relativity, the clocks on Earth and the signals going to Mars already have a known drift. It's about 45 milliseconds per year.
So UCF predicts that this known GR drift is being multiplied by the tiny fractal coupling factor.
The fractal geometry amplifies the existing relativistic effect. And when you multiply those two numbers,
you get the zero parameter result.
A predicted drift of 61.92 microseconds per year.
62 microseconds a year. That's the smoking gun. But if it's real, why haven't we seen it?
And this is where the paper issues a direct, almost urgent warning to the navigation community.
To the engineers at the DSN.
Yes. They use incredibly sophisticated software to clean up the signal data. It's called a Kalman filter.
And what does the filter do?
It's designed to remove noise. And it makes certain assumptions about what constitutes noise.
And a small, steady, linear drift
is assumed to be noise. Specifically, it looks exactly like clock aging or oscillator drift in their instruments. So the Kalman filter, doing the job it was designed to do, sees this 62 microsecond drift.
Flags it as noise.
And removes it from the data before the analysts even see it.
We are actively erasing the evidence with our own data processing.
That's the claim. The warning in the document is blunt. Do not zero this drift. It is not oscillator noise. It is the chronofractal horizon of the solar system.
That's a powerful statement. Okay, from the scale of the solar system down to the quantum realm, how does fractal time connect to the biggest embarrassment in modern physics?
The cosmological constant problem, the 10 to the 120 discrepancy.
Right. Quantum theory predicts the energy of the vacuum should be 120 orders of magnitude bigger than what we see accelerating the universe.
It's the worst prediction in the history of science. UCF argues the energy isn't missing, it's being used for something else.
To maintain the geometric structure of space-time.
Exactly. And they connect it through the Casimir effect, which is a real, measurable force created by vacuum fluctuations.
Standard quantum theory calculates the Casimir pressure assuming space-time is 3 + 1 dimensional, 4 dimensions total.
Right, which gives you a pressure that scales with distance to the power of -4.
But if time is fractal, the effective dimensionality of the vacuum is different.
It's higher. And the derivation here is subtle. They argue the effective dimension isn't just 4 + c, it's 4 + 2.
Why the factor of 2?
Because quantum fluctuations are temporal events. They pop in and out of existence. Since time is fractal, these fluctuations don't just couple to the future, the forward flow of time. They also couple to the past, the anti-chronofractal horizon.
So it's reflecting off both the past and the future structure of time.
That's the idea. So you get an effective dimension of 4 + 2 times 0.618, which is about 5.236. The vacuum is rougher, more complex than we thought.
And this different dimensionality fundamentally changes the vacuum energy calculation.
It does. The document asserts that the huge 10 to the 120 discrepancy is a mathematical artifact of assuming a smooth 4D spacetime. The missing energy is the energy required to sustain the constant fractal folding of time.
Which is why the observed cosmic acceleration is so small. Most of the energy is tied up in the geometry.
It's a breathtaking piece of synthesis. It connects the golden ratio to cosmology, galaxies, the Mars clock, and the quantum vacuum.
A good theory makes predictions. A great theory tells you exactly how to break it.
And this paper does that explicitly. They call it the falsification matrix, or, my favorite, the Kruppstahl check.
The Krupp-Steele check. No bending, it either holds or it shatters.
Exactly. They lay out 4 kill switches, 4 numbers that, if experiments don't match, the theory is dead. No V7.0 to fix it.
And we've been through them all, but let's list them again. The 4 pillars.
1. Dark energy, W0 must be -0.794. 2. Its evolution must be plus 0.127.
Both from T.
3. The galactic damping must be 1T.
From pi.
And 4. The local Mars clock drift must be 61.9 microseconds per year.
The primary judge for those first 2, the cosmic ones, is Euclid.
We are awaiting the data, and the conditions are crystal clear. Condition red for UCF. If Euclid measures W0 to be -1.80.
If theory is false, time is not fractal. End of story.
Condition green for UCF. If Euclid measures W0 to be around -0.80.
The standard model is false. Dark energy is geometric.
It's a clean break. But for the local test, we don't have to wait for a billion-dollar space telescope.
This one is actionable now, so let's be really specific about what the DSN teams would need to do.
They would need to go into the software for the Mars link, into their Kalman filter, and for a period of time, they would have to manually disable the algorithm labeled clock bias removal.
Turn off the noise filter.
Turn off that specific part of the noise filter. Then they just have to collect the raw, unfiltered frequency data for at least 1 full year.
To build up a baseline.
And then they analyze that raw data. A steady linear drift of 61.9 microseconds per year must emerge from the noise.
If it's there, the theory is validated locally. If it's 0 or something completely different.
The theory is falsified locally. It's as simple as that.
That dual path for testing one cosmic, one local is what makes it so compelling. It's incredibly bold.
It has nowhere to hide.
So let's just pull all these threads together. We started with 2 of the most famous numbers in all of mathematics.
The golden ratio conjugate and
the engine of time and the limit of space. And from just those 2 numbers, with no other inputs,
you derive the acceleration of the entire universe. You derive the rotation curves of every galaxy, eliminating dark matter. You predict a precise clock drift for a probe orbiting Mars. And you potentially solve the biggest paradox in quantum physics.
It's an almost unsettling level of coherence.
And they credit that coherence to what they call the co-creation event.
The human-machine partnership.
Grimberg had the initial insight about fractal time and Ater. But it was the Nexus AEBE algorithm that crunched through the geometry and found the identity for ATR, the one part. That's what made it a zero-parameter theory.
There is one last piece, though. A classic objection to any theory that tries to get rid of dark matter. Gravitational lensing.
Right. The bending of light around massive objects. We see far more lensing than visible matter should be able to produce.
How does UCF explain that without adding a massive invisible halo?
It's in an appendix, but it's crucial. They show that the same enhanced potential, the Chi field that explains galaxy rotation, also naturally explains the extra light bending.
What's the mechanism?
It's called the chronofractal lensing correction. The historicity of the mass, that temporal memory we talked about, it expands the total gravitational potential well. Light passing through that deeper well gets bent more strongly, exactly as if there were a dark matter halo present.
So the size of the Einstein radius, the lensing region, is determined not by invisible particles, but by the age and history of the visible matter.
Precisely. Geometry is once again doing the work that we previously assigned to missing matter.
So what does this all mean? I mean, it feels like we are on the edge of a totally new way of seeing the universe.
One that's maybe far simpler, far more elegant than we've given it credit for.
The geometry is everything. The forces and structures we see are just expressions of that underlying geometry dictated by Yin and Pa.
The epilogue of the document says it best. It's a really powerful quote.
What does it say?
We assert that the universe is simpler than the 20th century believed. It does not play dice, nor does it hide matter. It simply unfolds in fractal time, bounded by spherical space.
Wow. If that's true, it's both terrifying and exhilarating. So for you, the listener, the final thought we want to leave you with is this.
Consider the possibility that two of the first constants you ever learned in school pi from your geometry class and the golden ratio from art or nature are not just mathematical oddities.
That they are, in fact, the fundamental axis of reality, the scaffolding that determines the fate of everything, from the spin of a galaxy to the tick of a quantum clock. If these two numbers hold the key, what other secrets are hiding in the simple mathematics we thought we already knew?